And now what I want to discuss is inequality. So basically we're going to do the same thing that we did last time. We did equations in one variable, okay? But now instead of an equal sign, we're going to have an inequality sign. So what's an inequality sign? A greater than, a less than, greater than or equal to, less than or equal to. Do you know what I'm talking about? So that's what we're going to do here. So that's 2.5. And these are linear inequalities in one variable. Because again, later we're going to talk about linear inequalities in two variables, which the way we handle those is different. Okay, so first let's get the definition out of the way. What's a linear inequality? In one variable, well, it's an expression that can be written in the following form. So ax plus b less than or equal to c, or ax plus b less than c, or ax plus b greater than or equal than c, or ax plus b greater than c. Okay, where a, b, c are real numbers, and of course a is different than 0, because if a is equal to 0, we don't have the x, so there's nothing to do. And when I say x, it could be any variable, it could be t, b, whatever. Okay, so the reason why you have 4 expressions is because, you know, this may come in 4 different forms depending on the inequality that we have. Okay, so remember that the rule is that when you have this symbol, first of all, the little line below means or equal to. Okay, and if it doesn't have the little line below, then equality is not allowed. So when you use this symbol, the pointy thing, the thing with the point, goes to the smaller term. Okay, and the mouse, like the thing that opens, goes to the bigger term. So for example, this one reads the left side is less than or equal to the right side. This one reads the left side is less than the right side. Now this one, because the smaller guy is on the right, then that means this guy is the bigger one. So the left side is greater than or equal to the right side. And the last one, the left is greater than the right side. Is that okay? So pointy thing goes to the smaller one. And what does it mean to have a solution? A solution means, you know, it's a value that when you plug it into the variable, you get a true statement. Okay? The simplest type of inequality that you could get is something like this. Here there's nothing to do. Okay? For example, let's see, who can read the first one? How do you read the first one? X is less than or equal than 3. Yes? The second one? X is less than 3. This one? X is greater than or equal than 3. And this one? X is greater than 3. Okay, let's see. Who can give me a solution for the first one? Why 3 doesn't work?
Because it's not less than 3.
But what does it say?
Oh,
the first one.
Okay, so
less than or equal to. So equality is okay. So for example, x equal 3 would be a solution there. Do you understand this? Now, are there more? Give me another one. So we have 3. What else?
9 over 2.
9 over 3 is 3. So what else? 2, 1, 2.5. I mean, it doesn't have to be it, right? Negative 1,000. I mean, there are infinitely many solutions now. Anything that's less than 3 works. You understand this? So we cannot just write a bunch of numbers. So there is a way for us to write down the solution, and that's what I'm about to show you now. There are actually 3 ways to do it. Okay? So we have the graphical approach. So there is a way to show a picture that shows this solution set, because it's a set. The set is just a collection of elements. Okay? Then there is something we call the interval notation. That's the way that we typically give the solution. Typically we show the picture and then the interval notation. And then there's another one which is called set builder notation. So in this little table, I'm going to show you how we write the solution for each of these cases. Because every linear inequality in one variable boils down at the end, when you finish solving, to something like this. Okay? The x on one side, the symbol, and then the number on the other. Then you need to know how to write this down, how to write the answers down. Okay? That's what I'm going to show you here. So first, I'm the column that says solution, and we just verbally write, you know, in words, and we write what the solution is. Like for example, in the first one, what's the solution? All real numbers. So all real numbers that are less than or equal to the number 3, right? Anything that's less than or equal to 3, will be a solution. Now, how do we show this? Well, the graphical solution is the following. We draw the number line, okay? Then 3 is a point in question, right? Here's a 3. Let's let the ghost right. So here is a 3. So now the first thing that we need to decide is whether 3 itself is a solution or not. So in this case, is 3 a solution? Okay, so the convention is that when 3 is a solution, what we do is we're going to do a circle around 3 and we're going to do a dark circle. We're going to close it. Okay, in other words, we're going to do this. So we're going to do a circle and then we're going to fill it in. Okay, so here we're saying that 3 is part of our solution. And then we're going to decide, the real line, the number line is split down into 2 pieces. The right of 3 and the left of 3. Which one of the 2 pieces do we need to take for our solution? The right or the left? The left, because smaller numbers are to the left. Yes? So we do something like this. And then you chain that part. So somebody walks in and they look at that, they know that the solution is everything that's less than 3, including 3, without having to look at the inequality itself. Do you understand this? That's a graphical representation of that. Now, what's the interval notation? We just want to write that interval as an interval now. We want to use a notation for that. So the interval notation, basically, you read intervals from left to right. So look at the picture. Where does the picture begin from left to right? So this goes all the way to the left non-stop, right? So what's all the way to the left non-stop? Negative infinity. So we are coming from negative infinity, and where do we stop? At 3. So from negative infinity up to 3. Now, infinity is not a number, so for infinity, we always use parentheses. Okay? Now, we need to say here, how do we say whether 3 is part of the solution or not? So closed circle means it's part of the solution. So what closed circle means in this case? We use a square bracket. Okay? So when you put a bracket like this, you are telling me that 3 is part of the solution. So every number less than 3, including 3. So less than or equal to 3. Do you understand this notation? Closed circle means square bracket. Okay? And infinity is always parentheses because you don't include infinity. What's infinity, right? It's just an idea. It just keeps going non-stop. Okay? And then finally, subbitted notation. We use these curly braces. This means that you're about to write a set. A set is just a collection of elements. And then we basically say, okay, we put an X here saying this is the set of all real numbers X. We draw a line. This line means such that, in some places, you could also write 2 dots. It also means such that, so whichever you prefer. I like to use the line, so I'm going to be using the line. Such that, and then you're going to put here the condition. What does it mean to be in this set? And the condition is exactly that inequality. So subbitted notation is basically just repeat the inequality, but you put inside a set with this notation. So this means all real, the way you read this is all real numbers X such that X is less than or equal than 3. Okay? That's the way you would read this. We're not going to use most likely this last one. Okay, this is just for your knowledge because in all courses you may see it. But what we're going to be using when we solve inequality is a picture and then the interval notation. That's widely used. That's what we're going to be focusing on. Okay, but it's good to know all the ways. Okay, are there any questions on this first convention? Now, as you can imagine, the same holds for the others. The only difference is that when you don't have the equality, when you have a strict symbol like less than or greater than, what do you think is going to change? What do you think we're going to do in this picture? If we have a less than, we do an open circle, so you don't fill it in. Okay? Open circle means it's not part of the solution. And then when you do the interval notation, what do we do here? A parenthesis. The parenthesis means don't include that point. That point is not part of the solution. The bracket tells you include the point. The parenthesis says don't include the point. That's all. Okay? So I'm just going to finish filling the table. Okay? So the next one is all real numbers that are strictly less than 3. So this time equality is not allowed. So solution will look like this. Here is our 3. So we do an open circle, don't fill it in, and then we go left because that's where the numbers less than 3 are. Okay? And the interval notation then will look like this. This time we put a parenthesis. no square bracket. And then the set builder will be for real numbers x such that x is less than 3. Are we okay with this? So now similarly with the greater than or equal to, solution here will be all real numbers greater than or equal to 3. And then the picture is just like what we did above. We put the 3 here. Should I include 3?
No, yes.
Yes, right, because equality is allowed. So the little lines tells you that you should include. Now this time, where do we go? Do we go right or do we go left?
Right.
We go right because the bigger numbers are to the right. Yes? Okay, so as a picture, and what's the interval notation?
It will be,
Remember, you always write from left to right.
yeah,
So where do you begin? Just look at the picture. The picture tells you what to write.
bracket,
So square bracket,
3,
3,
comma, infinity.
and then positive infinity, we just write infinity. You could write positive infinity or just infinity. Okay? So once again, the bracket tells you that 3 is part of solution. The closed circumference bracket begins at 3 because this picture begins at 3 and finishes all the way to the right. So we have that is positive infinity. You okay? Remember, you write from left to right. And then interval notation, subject notation is just this. Questions? Okay, and then the one below is exactly the same. You just need to compensate from the fact, adjust the fact that x is cannot be equal to 3. So open circle and parentheses here. Okay, that's all. So all real numbers greater than 3. And then the picture, here you have your 3, open circle, and go right, and you change that. So parentheses, 3 comma infinity. And remember, always parentheses around infinity, regardless of whether you include the endpoint or not. But infinity is always parentheses. Okay. Questions? Now we're going to do examples of more complicated ones, but every linear inequality reduces at the end to one of these cases. Once you are here, then you draw your picture and you write your interval notation. Okay? So, how do we solve linear inequalities? Well, the good news is that we do exactly the same thing that we did for equations. Yes? Remember that these notes are available, okay? You know where to find the notes? On Blackboard, there's a little link that says lecture notes. Click it, take you to this note. Okay? So, how do we solve linear inequalities? Exactly the same way that we solve linear equations. Moving things from left to right, simplifying, isolating the variable. Exactly the same thing, combining like terms, etc. The only difference is, the only thing that you have to be careful about is the following. If you multiply or divide by a negative number, you have to flip the inequality. Okay? That's the only thing that you have to be careful about. Remember, when you're solving an equation, you can multiply or divide by whatever you want. In particular, you could do so by a negative number. If you do that here, you have to change. If it says less than, then you have to write a greater than. If it says greater than, you need to write a less than. Okay? For example, let's see. How does 1 and 2 compare? Which one is smaller? So what should I write here? 1 is less than 2. Let's go ahead and let's multiply both of these sides by negative 1. Okay? So I'm going to multiply both sides by negative 1. So we're going to have 1 times negative 1, and then 2 times negative 1. Yes? So what is 1 times negative 1? Negative 1. What's 2 times negative 1? What is it? Negative 2. Okay. Which one is smaller? So how do you know whether a number is smaller than another one or not? Just think of them on the number line, whichever is further to the left, right? That's how you compare two numbers. You put them in the number line, whoever is further to the left, that's a smaller number. So 1 is further to the left than 2, yes? But then you have your 0, negative 1, and then negative 2 going to the left, so negative 2 is smaller. Everybody okay with this? So now I should write this symbol. Remember, the pointy thing goes to the smaller guy. You understand this? But be careful. 1 is less than 2, but if I multiply by -1 both sides, the symbol changes. Now we get -1 is greater than -2. Is that okay? That's why we have this little rule here. And same thing if you were to divide. So just be careful. Because you know, this is typically where students make mistakes, like you forget to flip. And then that's it, you get the problem right. Alright, so okay, let's do some examples. I'm gonna give some problems and then we're gonna solve it, and then we're going to write the answer in 2 ways. We're gonna write the interval notation, and so we're going to graph the solution. Actually, there are 3 ways. We're gonna graph it, give the answer in interval notation, and then let's do submit just to practice. Okay, that's what we have on the table. All right, so let's see. Let's start with something very simple. So let's do 2y plus 6 less than or equal than 4. And then let's do -2x minus 5 less than or equal than -25. So let's do these 2 first. Okay, again, just do this the same way that you would do a linear equation. Okay, exactly the same thing. Just be mindful that if you're going to divide or multiply by a negative, you need to flip. That's all. Okay. All right. Let's see. But our job is to isolate y. So what do we do first? So we move the 6 over, right? So it's positive to the left. We move it negative to the right. So we have the 2y. We're subtracting, so that's not a problem. Okay. You don't have to flip anything. It's only when you multiply or divide. Okay. So just bring the 6 over. So we get 2y is less than or equal than, what's 4 minus 6? -2. Okay? And now we divide by 2. Now 2 is positive. Do I need to do anything with the symbol? Should I change it? No, it stays there because 2 is a positive number. Yes? That's not a problem. So we get y less than or equal than -1. Do you understand this? So that means as long as y is a number that's less than or equal than -1, you put it in there and it's gonna work. It's gonna make that a true statement. Okay? If you pick something bigger than this, you put it there, it's gonna be false. It's not gonna be true. Okay? As promised, it reduced to something like what we have on the table, so now we can easily answer the question. So you know, this is your inequality. Now we need to graph the picture. What's the picture? We put a -1 in here. Should we include -1 as part of the solution? Yes. So we do a closed circle, and then where do we go? Right or left? We go left because the numbers less than are to the left. Is that clear? All right. So now part A asks you to write the answer in interval notation. What would be the interval notation?
Plus comma
So negative infinity, comma, square bracket. Remember, just the picture tells you, just write from left to right. Where are we coming from? We're coming all the way from the left. What's there? Negative infinity. Where do we stop? Where does the chaining stop? At -1. That's what you write here. -1. Okay? And then the bracket because the closed circle. All right, and then part B, it says to do it in set-bit notation, so you just repeat what we have in there. Well, this time is y. So real numbers y, such that y is less than or equal to -1. Yes? All right, so let's see, do this one. So again, move the -5 over, so that's -2x. Less than or equal than -25 plus 5. Simplifying, we get -20. So now what do we need to do to solve for x? We divide by -2. Now, -2 is negative. So what do we need to do? Flip the sign. So now, we need to flip this guy. Instead of less than or equal to, we need to write greater than or equal to. Okay? Just flip it. So you get that x is greater than or equal than, what's -20 divided by -2? It's +10. Did you understand this? Do exactly the same thing. Imagine that you had an equal sign. This is exactly what you do, right? Move the negative 5 over and then divide by negative 2. The only thing is that because it's a negative, you have to flip the inequality. That's all. All right. Draw a picture. So it says greater than or equal to. So we should do a closed circle here, and then we go right and shade that dot. Do you understand this? Okay. So then let's write the answer in interval notation. So we begin at 10, right? It's from 10 to positive infinity. So we do a bracket because of the closed circle. And then all the way to positive infinity and then parentheses. Remember, around infinity is always parentheses. On set-bit notation, this is also real numbers x, such that x is greater than or equal than 10. Remember, this line reads as such that. Okay, that's how you read that line. Okay, questions? Okay, so let's do one that has a little bit more stuff to it. For example, 3 over 4 times ay minus 9 less than 3. And then let's do 1 plus 4 times b minus 2 is less than 2 times b minus 5 plus 4. So I repeat, just solve it just like if it was an equation, okay? Just be careful if you divide and multiply by negative. All right, so what should we do first in number 3? Let's see, you could distribute the 3 over 4, yes? This is fine because the 4 and the 8, they're gonna cancel nicely, right? 8 divided by 4 is nice. But how about 9 and 4? With this 4 cancel with the 9? No, so you're going to end up with the fraction anyways, then you have to deal with that. So let's avoid trouble and get rid of the fraction right away. Okay? So let's get rid of the 4. And how did we do that last time? We multiply by the LCD, which in this case is just 4, right? Or another way to look at it is this 4 really just divided this part right here. Okay? So just move it over here and multiply. Does that make sense? So let's just get rid of the fraction right away. So the 4 is dividing, so I'm going to move it to the other side, multiplying, which is equivalent to multiplying both sides by 4, okay? If you multiply both sides by 4, the right becomes this, and the left will be times 4, but then the 4 cancels this one, and you end up with this, okay? Exactly the same. Now, 4 is positive, so there's no need to flip anything, okay? And now we do as usual. So on the left side, what do we need to do? We distribute, so what do we get? 24y minus 27 is less than 12. And now we move the 27 and then divide by 24. So 24y is going to be less than 12 plus 27. So let's just do it now in one shot, right? So we get a 39. And just add a 27 to the other side. Is everybody okay with this? This is typically what we write, okay? Typically, we don't do plus 27 and then another line. We just write this. Is everybody okay with this? All right. Now, what do? Divide by 24. 24 is positive, so nothing to worry about. So now, before claiming that we're done, question. This is a fraction. Is this in lowest terms, or we can simplify this more? So let's see, do they have a common factor? For example, they definitely don't have 2 as a common factor. This one has a 2, but this is not even, so 2 doesn't work. How about 3? I'm going to give you a quick tip. To see whether a number is divisible by 3, you can do the following. Add up the digits of the number. If you get a multiple of 3, then the number itself is a multiple of 3. For example, 24 is 2 plus 4. what is it? 6. Is 6 a multiple of 3? Yes, so you can divide this by 3. Now, how about 39? What's 3 plus 9? 12. Is 12 a multiple of 3? Yes, so you can divide it. Indeed, you divide this by 3, you get 8. At the top, you get 13. 13 times 3 is 39. Okay? So we could simplify this more. Take out a 3 from here, and you get 8. Take out a 3 from here, and what do you get? 13. So we get 13 over 8. So y is less than 13 over 8, and this now is in lowest terms, because 8 only has 2's in it. 2 times 2 times 2, and this is just 13. Nothing to cancel. Okay? Questions? So now, once you get here, as promised, this is just like in the table. Now we draw a picture. So, number 9, you don't have to put 0 or nothing. Just put the number in question, which in this case is 13 over 8. And then we decide, should we do open or closed circle? Open circle. Where do we go, right or left? Go left. And the moment that you have your picture, then the rest is automatic. Interval notation. Negative infinity, comma, 13 over 8, parentheses all the time, and then the separator notation. Be this guy. You okay with this? Okay. About number 4, what's the first thing that we should do? So remember, once you see something like this, just work on each side of the expression. Before moving things around, just simplify as much as you can each side, and then you start moving, switching things around. Okay? So let's focus on the left, and at the same time, we focus on the right. So let's see, on the left, we can do something about this guy, right? Just distribute the 4. So we get 4b minus 8, 4 times negative 2, less than, and then on the right, we work on this guy. So distribute the 2. So we get 2b minus 10, and then plus 4. Okay, now let's simplify whatever we can. Let's see on the left. Can we combine something on the left? So we can combine the numbers, right? The 4b stays there, but then we can combine the 1 and the negative 8. So 1 minus 8 is negative 7. And then the 2b stays here, and then negative 10 plus 4? Negative 6. Okay, so that's a b, and the other one is a 6. Okay, make sure that you understand how we should do this. Okay, so now we simplify as much as we could each side. Now it's time to isolate b. So remember, bring b to one side, the numbers to the other. So I'm gonna switch the two things, right? So 2b, I'm gonna bring it over here, and then the negative 7, I'm gonna bring it over here. Everybody okay? And when you do so, you need to change the sign for each of those, okay? All right, so it will be 4b minus 2b less than negative 6 plus 7. Okay, just change the sign. When you change something from one side to the other, you change the sign. So simplifying, we get 2b less than positive 1. Negative 6 plus 7 is 1. And then divide by 2. 2 is a positive number, so nothing to worry about. We don't have to flip it. So b is less than 1. Questions? And once you get here, you draw your picture. Here is 1/2, open circle. B is less than, so we go left. And then you write the answer in however form the problem asks you. In this case, we need to do interval notation. And we also need to do separator notation. Questions? I mean, every other problem is just the same. It's just that, there could be fractions involved. So I guess let's do one with fractions, and then we can probably call it a day. Okay? But I mean, it doesn't really get, more complicated than this. Something like this, and then with fractions involved, and then that's what really there is to it. So let's see, let's do number 5. Let me write negative 2 over 3x minus 1 over 3 greater than 1/2 x. So remember, 1/2 x, that's the same thing as writing x over 2. So you will understand this. And negative 2 over 3x, the same thing as writing negative 2x over 3. So if that bothers you, for example, you can just write it. You can just rewrite it like this. If it makes makes it easier for you to look at. It's the same thing. All right. What's the first thing that we should do?
You will move negative 2x over 3 to the other side.
Yes, but then again, you have to combine the fractions. If you are okay with that, that's fine. My advice, just get rid of fractions. Okay? Just get rid of the fractions. Then the problem becomes very easy. Okay? So, but then the question is, okay, how do we get rid of the fraction? What is it that we need to do here? Multiply by what? You find the LCD. Remember, it's the minimum common multiple. So look at the denominators. LCD is least common denominator, which when you just look at the number is the minimum common multiple. So one number is a multiple of both 3 and 2.
Of 6.
It will be 6, right? Or to look for the smaller one, 6. So you can divide 6 by 3 and you can divide by 2 as well, right? So we multiply everything by 6. So everybody okay with this? So here the LCD is 6. So I'm going to multiply every single term by 6. So we have negative 2x over 3. Let me just leave a space. So I do times 6, times 6, times 6. Yes? Now remember, when you multiply by 6, once again, there is a secret over 1 here. So remember, when it comes to fractions, whatever is on top can be simplified, whatever is in the bottom. You can do that vertically or diagonally. Okay? Anyways, all of this is part of the top, and all of this is part of the bottom, after all. Okay? So this 3 down here can be simplified with the 6. And what do we get? What happens when you cancel the 3? What do we get here? Plus 6 divided by 3.
Upside 2.
You get 2. So then you multiply. Negative 2x times 2. That's negative 4x. Is that clear? Let's go to the next one and repeat. You cancel the 3 with the 6. What do you get on top? The 2. So then 1 times 2 is just 2. So minus 2. Then greater than, cancel the 2 with the 6. What do you get? 3. So then 3 times x is 3x. So by multiplying both sides by 6 and simplifying, now we change the original expression, the original inequality with this one. This one is simpler. This one has no fractions now. Okay? So all you have to do is move things around. So you could, as usual, you could just bring the x to the left, numbers to the right. But for example, just to change the dynamic a little bit, I'm going to bring the x's to the right now. Okay? Just to do it a little bit differently. And also the reason for that is the following. If you bring this x to the left, it's going to come negative, right? And when you combine with the negative 4x, you're going to get another negative. So that means that you will have to divide by that negative 7, then you will need to flip this sign. That's fine, but then you have to flip a sign. However, if I bring this negative 4x to the right, it's going to come positive. Does that make sense? So when you divide by 7. You don't have to flip anything. Okay? So that's why some people in situations like this, they will go right instead of going left with the x, just to avoid flipping the sign and that. Okay? But you do it however you want. Anyways, just so that you see it differently, I'm going to go to the right. So the 3x is here, and then the negative 4x, I'm going to bring it here positive. Now, the thing is that you have to understand how to read this, okay? So now we divide by 7. So we get negative 2 over 7 is greater than x. No need to flip anything. Now, how do you read this? This means negative 2 over 7 is greater than x. What is another way of saying this? X is less than negative 2 over 7. You understand this? If this guy is bigger than x, that means x is less than this, right? So if you want it, for example, then you could rewrite this as what you're used to. Okay? Anyways, it's exactly the same thing. Does that make sense?